Hello learners, this session we are going to see how we can able to practically implement the load balancing in a cloud sim environment. You are supposed to import the necessary libraries to your application. So in your application, you are supposed to have your cloud sim. So for cloud sim, we have cloud sim and ng, a host list, cloudlet list, and virtual machine list. Additional to this, the provisioners, that is the storage, processing elements, bandwidth, all those provisioners have to be incorporated in your application. So all this has been imported in your record. We are supposed to have the cloud list to be declared, the cloud list as well as the virtual machine list we have been declared. And moving on to the main code of execution, as of initial stage, we are supposed to have initialization of the cloud sim environment. To initialize the cloud sim environment, we need the number of users going to request for and the timestamp value in order to record each and request. What is the time that have been made use in order to complete the task. We are generating the calendar using the calendar and get instance method. We are going to have the timestamp value and tracing each and every event. We are just going to have the trace flag. But as of here, it is going to be simple application. We are making it as a false. So these are the three parameters that are mandated to have the initialization of a CloudSIM environment. So CloudSIM.init, where you are just going to initialize a CloudSIM environment using the number of users, the timestamp value is in with respect to the calendar, get instance method, and trace flag. So once you have been initialized the CloudSIM environment, we are just going to create a data center. So for creating a data center, we are just going to have the create data center method. So this create data center method, which invoke the functionalities in creating data, having the to be adopted. Okay, so create data center, we are just going to ask the name of the data center and the host list. So the specifications to the host is million instruction per second is going to be, and the RAM is going to be 2000 feet, and we have the storage capacity and bandwidth. So we are specifications to our host, and we are going to have the processing element to be fixed on. So this processing element we are just going to add with the processing element is simple. Not only this, we are just going to have the host with in terms of the ID is going to be 0, the ID is 0, and the RAM provisioner, that is availability 2000 with bandwidth in a simple of 10,000. So we are adopting a host. We are having the specification, host specifications to the data center. We are going to have uh, 3 hosts that are being created for this particular data center. So we have additional features that are related to your data center is going to be the architecture which has been followed is x86 system architecture, and the OS is Linux OS, and VMM is going to be the virtual machine monitor is going to be the same. The time zone is going to be 10.0. The cost that are accompanied is 3.0. Cost per memory is going to be 0.05. Cost per storage is going to be 0.001 and cost per bandwidth is going to be 0.0. With these additional features, we are just going to create a data center environment. So a new data center can be able to be created with the name that has been passed through the method and the additional characteristics that evolved over to the peculiar host representations. So all those will be evolved in your data center. So we have four specifications. Following the specifications is going to be 1000 million instructions per second, and the RAM is going to be 2048, and we have the storage capacity of 1 that we are going to have a broker of it. So for a broker, we are just going to pass the message, and having the broker ID for each and every broker we have an ID. So broker ID will be generated. For this broker ID, we are just going to have provisions to be adapted to. So for virtual machines that have been adopted, we have the specifications to virtual machines. Million instructions per second is going to be 1000 and the size is going to be 1000. We are going to access the size to be 10,000 megabyte, 1000 megabyte. RAM is going to be 512 and bandwidth is going to be 1000. The processing number is going to be the number of CPUs which are going to accommodate one, and we have the virtual machine monitor is going to be Z. So with this specification, we are going to create virtual machine. So virtual machine, we are just going to pass the ID and we have the broker ID to it, and we have the specifications to all the virtual machines that we have been declared here. So we are adding to the list. So each virtual machine has been added. Here we are having the 5 virtual machines to be adapted to this environment. So once we have been added to the virtual machines, we are submitting to the broker. So broker is a coordinator where it coordinates between the virtual machines and the task which has been assigned. The next step is going to create the cloudlets or the jobs which has been assigned. So we are going to have the specifications to the cloudlet list. So length is going to be 40,000 and the file size is going to be 300 and the output size is going to be 300. We have utilization model that can able to utilize the model to be full, which means that we are going to use the full CPU and bandwidth as well as the storage. So in this, all these 3 resources which has been utilized in a proper way. So each and every cloudlet has been created using new cloudlet, passing the cloudlet ID with the length. We have been specified the specifications over here. Okay, as we said that the utilization model is going to be full utilization model full, that has been represented in terms of RAM, bandwidth as well as the CPU. So once you have been added all the cloudlet to the cloudlet list, so this cloudlet list have to be submitted to the broker in terms of submit cloudlet list. So this broker is going to be the coordinator between your virtual machines and the jobs that has been assigned. So now moving on to the mandate part of your instruction, that is your round robin virtual machine allocation method that has been adopted for the broker. So this is going to be the basis in order to have the load balancing to be adopted for your CloudSIEM environment. So I am just going adapted the cloud list as well as the virtual machines. Both are in coordination with the broker. So now we are passing this broker to the round robin method. So in the round robin virtual machine allocation, so this has been, the method has been called in order to invoke your particular process. So we are just going to have the broker is going to be the pass. So in order to have the broker, we have the whatever the list that is submitted to the broker, we are going to have it in terms of .get cloudlet submitted list. So we have the list of cloudlets, that is the list of jobs. We are just going to have the virtual machines that has been indexed, and we are going to bind it to virtual machines. So how we are going to bind it? We are going to adopt a round robin method to be adopted for virtual machines. So we are passing the as well as getting the virtual machine ID, and in a round robin way. This is the where we are just going to accompany each and every virtual machine. So each and every cloudlet will be assigned to the machine. So in a round robin. So at the first time, virtual machine 0 has been added means the next cloudlet will be assigned to virtual machine 1. Next time, virtual machine 3. So in a round robin way, we are just to adopt each and every cloud, the jobs to the virtual machines. So this is the statement where we are adapting the round robin fashion. So this has been adopted. Once you have been the cloudlet and we have been chosen the policy, load balancing policy, then we are going to have a start simulation. So CloudSIEM.start simulation, where we are invoking CloudSIEM environment. Once you have been invoked your simulation part, you can able to automatically view the results. So broker.get cloudlet received list can able to invoke those results. On having the results, we are just going to have the various factors that governs to the received cloudlet received list. So the factors is going to be, we are going to have the cloudlet ID And what is the status? So for a completion status only, we are going to print it. We have a Cloudlet virtual machine ID. We have your actual CPU time, and uh, having the execution start time and having the finish time. So these are various features that have been adapted from the received list. So once you have been started the simulation, on the upon the simulation, we can able to identify the ID, Cloudlet ID, virtual machine ID, and the actual CPU time, actual execution start time, and finishing time. So these are the features that you can able to be generated in a Cloudless simulation environment, and we are printing those execution results. Once you have printed those execution results, we can able to end or stop the simulation process in a cloud sim environment. Cloud sim dot start simulation. So we are just going to have the cloud sim, that the results which have been received from the cloud sim environment, we are just going to print it. Okay. So upon executing this, we are just going to run the file. I am making scene. So what happens at the execution of the process? Okay. In this, we have 10 cloudlets. So for your 10 cloudlets, what is the status of it, and what is the data center which have been invoked, what is the virtual machine IDs to which it has been used for, and what is the time which has been make use of, what is the start time and what is their finish time. So out of which 160 is the total time that has been required to complete its task. So this is our basic theme behind our load balancing. So for load balancing, we are just going to ensure in a round robin way, we are just going to adopt each and every process to have utilizing the virtual machines to complete the task. Thank you.